Alright, most real-world data does not fall perfectly on a line. However, if the data on a scatterplot resembles a line, we can fit a line to the data, write a function for the line, and use this function to solve problems to make predictions. So what that means is after we draw the line, we can ignore the points that are on the graph because the line is what we should expect to happen in the future. The line that you use to represent the data is called the trend line. We will refer to the function you write for the trend line as the prediction function. It's just an equation there. The most common way to find the trend line is to use the eyeballing technique, which is why we get different answers for these. But there is a formal way to do it. We're just not going to do it here. You probably won't experience that, I think, either in high school either. So simply try to draw a straight line that best fits the data. Use a ruler for accuracy. No, you may use a ruler if you'd like, but okay. So if your straight line looks like that, well, that's no good. So we don't want it to look like that. Okay. But something like that, still kind of sloppy. So just be careful. I mean, we're not really looking for perfection, but it shouldn't be sloppy looking. Simply, directions in 1 and 2, observe the data sets and take note of any associations you see. Draw a trend line, write the prediction function using the form y equals mx plus b, and use your function to predict the value of y when x is, what did I say, 12 and 100. Okay. So here's number 1, and let's go ahead and draw our trend line. Something like this will do. Now again, my line's not perfectly straight, but it should be pretty straight. Okay. Now notice I'm not connecting the dots here. This is not connect the dots. This is just drawing a line to represent the data the best that we can. Some people call this the line of best fit. It just shows the trend of the information, which is why they also call it the trend line. But they are the same thing. All right. So what are some observations we see? Well, here are some observations we should see right here. Is as the x values, as the x values increase, the y values increase, giving us a positive sloppage. Bam. Alright, so that's a pretty good observation right there. I'd say that's pretty acceptable. Now, if this were a word problem, we'd want to include labels with those, but for now, that's going to work. Use a ruler. We did that, and we drew a line. Now we need to estimate good old sloppage. So here's what you'll be tempted to do to find the sloppage. Is you'll say, well, here's this point right here, this one, and then this point right here. Well, those 2 points actually are not on the line, so we're not going to use those, okay? You have to ignore the points from the original set of data and just focus on the line that we drew. So, for example, I got a point right here, and then I even got a point right here. Now, you could have used 2 other points, but I can see clearly that, yeah, I know that's a song, right? So I've got this point 0.2, but I've also got this other point 7.9er. Now maybe with the line you drew, you was a little bit off on that, so maybe you didn't use these 2 exact points, and that's okay. But the sloppage should be approximately what we find right here. So what the heck is that garbage? Looks like from here I would go upwards 7. So I got my sloppages up 7, and then to the right 7. So 7 over 7, this gives us Juan. Now down there they've got this M, and then instead of equals they've got this stuff. Those are curvy equal signs because it's more of an approximation. So M is approximately 1. So if you got something close to 1, 9/10, maybe like 11/10, something to that effect. This one right here it means approximately, which is actually a very long word. Approximately. So my sloppage is approximately 1. And then up in count, we already saw that the Y-intercept that we have is just 0.2. So that's approximately the Y-intercept. Of course, some of you may have thought, well, that line goes through a little bit higher or lower. Again, that's okay. It just depends on how you drew the line, which makes these extremely difficult to grade because I'm looking at each one extremely individually, and they are different, okay? So however you found that is okay. This one turned out pretty convenient for us. It was just 0.2. Well, now that we have that information, we can write a prediction function for the data set. And we can see the sloppage that we had was 1, and the Y-intercept was 0.2. So we'll use this prediction function to find the value of y when x is 12. So we'll need to write this out. But again, we're saying that down here that x is 12. So if I solve this, I would find that y is 14. So when x is 12, y is 14. We can write that as a point, 12, 14. But then on the next part, it says replace x with 100. So if I replace this with 100 and solve this, then I get 102. So this other point would be 100 and 102. There we go. And that's all they wanted from us right there. So the prediction function, like it did, it allows us to predict future values, which is where this gets really, really, really shady, especially if you're in some kind of politics. Because now, right, you guys saw that the line that we drew is subjective, because we're eyeballing this. Well, what if I was a really corrupt politician and the line that I wanted to draw was like this? I said, well, it represents the data. Now maybe I'm making myself look a lot better than I am, right?
Protesting straight lines.
Yes, thank you. So just be aware that some people use this kind of stuff for evil purposes, but that is not you. So, all right, observation. Here's the observation that I see on this graph. So as the x values increase, that would be going to the right on the graph. As the x values increase, the y values on this one, yeah, very good, decrease. This will give us what type of sloppage? Negative. Oh, not negative. Negative sloppage. Spelling's hard. There we go. All right, use a ruler and draw a trend line through the data points that captures the, what does that say? I can't see what that says. The general trend of the data. Okay. Let us draw a line. Now this one I'm kind of using a ruler on this. So here's the thing. I just want to show this to you guys. Hope you can see that line. Is I like this one right here. But again, if some of you guys had that adjusted up a little bit like this, I mean, that's still pretty acceptable, okay? Even if it was down a little bit right here, that's still pretty acceptable because we're just eyeballing this thing. And this is the beauty of technology. Not that it's always beautiful, but that's the line that I have. Now again, yours may be a little bit different, but at this point, we really want to ignore those other points on the graph, okay? The original points that were on there, ignore now. Well, there's the line of the trend line for me. Again, yours could be slightly different. But now we want to find good old sloppage on these. So Harmon brought up a good point. I can see that my line is going to go through this point 0.8, which is a very convenient point, which we will see. And it goes through several of these points, but I'm going to use this one, which is at 14 Juan. So when I find my sloppage, I can list them over here, 0.8 and 14.1, because some of us really like this rainbow method, right? So from 8 to 1, I would go down 7. So my sloppage right now is down 7. And then I would go to the right 14. So negative 7 divided by 14 is negative 1/2. So my sloppage is about negative 1/2. Again, yours may be slightly different, and that's okay, but it should be pretty close. Oh, so let me show you this, because perhaps, throw that garbage. Perhaps you did get negative 1. If you got negative 1, this is what your line should look like. Right here, okay? So now I assume it didn't look like that. So somewhere in the calculation we may have gotten that wrong. If you got negative 3, it would be even steeper like this one right here, okay? Now again, this is no good. We don't want that garbage. So just be careful on that stuff. Yeah. So we have our Y-intercept, which was at 0.8. And that, this is kind of a nice thing about this trend line stuff is, I mean, does that line go exactly through 8? Not necessarily, but could I make it? Yes, I definitely could. So we can kind of make that come out pretty convenient, especially when there's not a strong relationship like the last one, which is like this one. Let's write our prediction function for the data set. And we have it set up pretty good. So our prediction function, we have a sloppage. The sloppage that I have is, that should be negative 1/2. And then my Y-intercept is at 0.8. Bam, there's my prediction function. And it wants us to predict what the Y value would be if X were 12. So let's go ahead and put that in. We got Y equals, negative 1/2 X plus 8. And I'm going to replace X with 12. So if I solve this, I would get Y equals negative 6 plus 8. So my Y value should be 2. Instead of 12, we're going to have 100 there, right? So when X is 100, what is the Y? So negative 1/2 times 100 is negative 50, plus 8 is negative 42. So Y is 2, and then Y is also equal to negative 42. If you wanted to write those as ordered pairs, that would be fine as well. Person who is on a strict diet. So we got our weight, which is our y-axis, and the time in weeks is the x-axis, so the weight will depend on how many weeks have passed. By the way, on this graph, would we expect this pattern to continue forever? No, why?
Because, well,
You can't salad for that long.
yeah, you can't like lose so much weight. You just die eventually.
Very good, yeah. Yeah, if we followed this all the way down to 0,
He lost 50 pounds.
Why would you try to lose weight at 180? Like,
Yeah,
just
that's-
depends how old you are.
yeah, well, what if you were like 3 feet tall? You see what I'm saying?
You'd be like, that'd just be muscles.
Yeah.
No, literally, if you
Whatever.
were 3 feet tall and you weighed that much and you were just
Data points that captures the general trend of the data. So again, this is where we get to be very creative on this. I'm just going to start my line right here. This looks pretty good. I mean, if I wanted to, this line right here doesn't really, oh, it's not showing up there, but the one that I have isn't, it's not really fitting the data, and I can't really draw it way up in count, because that's no good either, so I'm going to leave it like these.
How do I scroll down?
Is this thing really gonna
scroll down?
burn for
Yeah.
$300?
It's this one.
Thank you.
You're very welcome.
So, the way I like to find the slope is I like to do, this method. And this is down,
Lacking so bad.
it's lagging so bad. This is down 20. This is down 20. Because it's actually going from 180 to 160. And then this goes, negative 20, sorry, it goes down. It's negative 20. And then this is 7. This is across 7. Yeah. So, from there, we can find that it is negative 20 over 7. Am I doing this right? And that does not simplify down. And then the slope, I guess, would be 180. Y-intercept would be 180. And the prediction function would be y is equal to negative 20 over 7 plus 180.
Oh. There we go.
What does the slope represent in the context? It represents you lose 20 pounds over 7 weeks. What does the y-intercept represent in the context? You started at 180 pounds. Predict this person's weight after 18 weeks if the trend continues. I would guess if they lose 20 pounds over 7 weeks, then they would lose,
It's finally coming.
wait, so 15,
Oh, dear.
it would be about one, it would be about one 100. Okay, if 20 equals 7, then half of that. 3.5, I mean 3 would be equal to little less than 10.
Okay, let me finish it for
Yeah,
you.
thanks.
You had the right idea though there, okay? So let's go back onto this stuff and see if we can. So this is his prediction function, and we want to know how much this person will weigh after 18 weeks. So if I multiply these, what do I get out of that? I get a negative 400, 360 over 7 plus 180. And yeah, we could estimate this garbage. I would just say use a calculator. So that is what I'm going to do. In my calculator, I'm going to put in negative 360 over 7, and then I will add 180, and the decimal value would be fine in this case. And I have 128, I'm going to round it to the 10th, 0.6 pounds. So that's using that function that he had there. Of course, if yours was a little bit different, you may have gotten something like 130, maybe even all the way up to like 140, okay? But it could have even been a little bit lower than that, and that's okay as well. You guys have questions on that? That was very good work. The following scatter plot shows the burn time for candles of various weights. So the burn time will depend on the weight. Hopefully that kind of makes sense for candles. I know you guys probably don't use candles anymore because of, cell phones and stuff, but whatever. Some people like to burn candles because they smell so stinking good. They smell good, right? Some of them do. A fire, yeah. Who doesn't like fire?
What's your favorite scent of candle? What's your favorite?
I like spring daisies and cinnamon.
Spring daisies.
And cinnamon.
Bonfire.
Okay. All right, whatever.
That sounds good.
Here's what I'm going to do. Excuse me. Hopefully I can make it through. I'm going to draw a trend line on the scatter plot. Now this one, since it is extremely separated, like there's a lot of distance between the points, it could vary quite a bit. For me, I don't want that color actually, I want a different color. Let's see if we can draw this pretty good. That looks pretty good to me. Now this one is coming out extremely convenient once again, and that's okay. Now again, yours may be a little bit different, that's alright too. But with this, it should make things extremely easy to find the good old sloppage and also the Y-intercept. So write a prediction function for this line of best fit that we drew. Alright, so I got this point right here. Looks like I got a point right here too. So I got one point at 0, 0, and the other point at 1280. So if I drew a triangle onto these, I went up 80, so that's my sloppage. I'm going up 80 and then to the right 12. And 80 divided by 12 is not a pleasant number as a decimal, but as a fraction we should get something pretty good. So 46, simplify again, 20/3. That's pretty close to what we had last time even. Y equals 20/3 x. Now all we got to do is find the Y-intercept, and we did that right here. Plus 0 if you want. You don't have to write that there though. But there's our prediction function. Explain the meaning of the sloppage and the Y-intercept. Alright, so this is a word problem, so we can write the context on it, these. Let's start with the sloppage. I'll put on my desk names. Forever, what do we got? 20 hours? 20 hours. For every 20 hours of burn time, the candle weighs 3 pounds. Now that's just a sloppage. Now we gotta identify the Y-intercept. If we don't burn it, it don't weigh nothing. That looks pretty good. Alright. Here's what we don't want. We don't want a slope that's something like 50. We also don't want a slope that's something like 1. Okay, those are too big and too low respectively. And we also don't want a Y-intercept that's 20, because, well, I guess I could see how 20 would probably fit there. What we don't want to see is 100 as the Y-intercept. That would be very bad. Okay, so there is a reasonable tolerance for how far off we are. But yeah, you don't have to have exactly what we have here. Use your prediction function to predict the burn time for the candle that weighs 40 ounces. 40 ounces is the weight, so that's our x value. So when I go in here, y equals 20/3, x now is 40. And plus 0, that's not going to matter. I get a y that's equal to 800 thirds, which, yeah, ounces. Yeah, sorry, thank you. Ounces. So, what do we get out of that? 66.6 repeating in hours. Yeah, that seems right. 2 with a remainder of 2. Yep, that's good. Well, if the candle burns out at 500 hours, predict how much the candle weighs. Well, that's 500 hours. That's the burn time, which is y. So now I got 500 equals 20/3 x. So all I'm going to do is divide both sides by 20/3. So I'll divide here by 20/3. And 500 divided by 20/3. And what do we get? 1500 over 2, 750. Yeah. 775. Yeah, it should be 75. X squared is 75, so it should be about 75 pounds. Now again, that's just 75 pounds for what I have. Yours may be a little bit different depending on which function you had. Okay. Software programs and graphing calculators can be used to draw trend lines, which is pretty nice. Izumai used a graphing calculator to generate the trend line for data on assists and rebounds. The graph below shows the trend line generated by the calculator. After creating this line of best fit, Izumai decided that it might be best to drop the outlier 326. You see how that's kind of manipulated there, right? That's this point right here. She's just saying, well, I'm going to ignore that point. Okay, well, let's ignore it. But is it reasonable to ignore that point?
No.
Why not?
Oh, yes, because it's like so off, I guess.
Okay.
I would say like no, because it isn't like including all of the data.
All right. Both of those are actually valid points. Well, what if this player joined the team midway through the season?
Then you wanna leave.
Yeah, now we definitely want to leave it out because if that person were given more time to play, perhaps they would have fit more into the data.
Yeah.
So circumstances depend. Again, this is where it becomes manipulative though, because sometimes they could say, hey, look, I've got this point here. Does it help me? Yes, then I'm going to keep it. If it doesn't, then I'm not. So even though it's an outlier, we can say we keep it or no. But honestly, it should be depending on what the heck happened there. All right, so now we've got this new trend line. So that having that point taken away did change the trend line. So in the formal mathematics for finding the line of best fit, yes, it does definitely change the trend line. Again, not that you have to know that right now. But analyze the differences in the two lines. What did the outlier do to the trend line generated by the calculator? Well, not having that outlier, it appears to me that it has become a more steeper negative slope. I mean, it was still negative, it's just this one appears to be extremely steep. So that is one difference. Write a prediction function for the trend line generated by the calculator with the data set that does not include the outlier. That's the one that we have. So let's see. This line doesn't go exactly through 0, 1, 75, so we can't say that it is that Y-intercept, which means we will have to find it, and that's okay. So let's see, we got y equals mx plus b. Let's find sloppage first. This point looks like is one that we can count on. That is 50, 100. And then, well, I don't see any others that we could use. 30, it's a little bit above there. They didn't help us out there at all. Well, I guess if we're making estimations, then let's just estimate the Y-intercept. That's fine. So there's 25 between those. I mean, it's above half, so maybe 170. I'd say it's a little bit less than that. Let's say 170. That seems right, because that's about a fifth of that. Okay, yeah, 170. So we're going to make this 0, 170. All right, so to find the sloppage on these, I find the difference between these two, so that's a negative 70. So my sloppage went down 70. And then from 0 to 50, that was to the right 50. And this simplifies to negative 7/5. So again, it's just a quick estimation there, but it should be close, whatever we get. And then we already declared that the Y-intercept was a 0, 170. That is our prediction function. Now I did use rainbow method there, it's just a little bit different there, how they were lined up. But you can line them up good. All right, explain the meaning of the sloppage in the Y-intercept. Let's do that. So the sloppage, let's see, what the heck. It's rebounds and assists. So for every assist, because this will make a little bit more sense, every 5 assists, that was our denominator. Assists, they lose 7 rebounds. That's the sloppage, the Y-intercept. If you have 0 assists, then you should get, how many did we say? Was it 100 and, yeah, 170, very good, thank you. You should get 170 rebounds. Now, of course, that's over the course of a season, so that's hopefully should be pretty reasonable, depending on how many games you play. E, use your function to predict the number of rebounds a random player would have if they made 110 assists. Assists are the X, so let's do that one first. Explain the limitations that the data exhibits. We'll get to that. So, we got 110 assists throughout the season, then 150. So in this equation, negative 7/5 times x, which in this case is 110, plus 170. Then we get y equals 22 times 7, negative 134, plus 170. So it looks like the y would equal 36. Yeah. So that means that how many rebounds? The first one is 36 rebounds. And then what about 150 assists? So I'm going to go back and change that. And these two. So now I got 150, 30, negative 210. So that would be negative 40. Well, negative 40 rebounds doesn't really make sense. You can't really lose rebounds or say that you have negative rebounds. So in this case, there is clearly a limitation on this. Explain the limitations. The limitation is that you can only have 0 of each. That's the minimum. It's not possible to get into the negatives on these, so it is only reasonable to use quadrant 1. Similarly, use the function to predict the number of assists a player would get for 150 rebounds. Alright, so 150 rebounds should equal negative 7/5 x plus 170. So if I subtract 170 from both sides, we can see 170. Then I got a negative 20. That's okay right now because we got this negative 7/5 x. So by multiplying both sides by, or dividing both sides by negative 7/5, we get 100/7, which is x. So 100/7, I don't know what the heck that is. 14 and 2/7. 14 and 2/7, that is assists. Which is okay. I mean, there's no limitations right there, but you can't get less than 0 assists, so we're in good shape there. And since this one would be a fraction, that's okay as well because we're just looking at some kind of averages and estimations. So if they did get 150 rebounds, you would expect them to get 14 or 15 assists throughout the year. All right, here I go. Most real-world data does not fall perfectly on the line, which is actually kind of good. However, if the data on a scatterplot resembles a line, we can fit a line to the data, write a function for a line, and use this function to solve problems and make prediction. The line that you use to represent the data is called the trend line. We refer to the function you write for the trend line as the prediction function. So again, just like we've been doing, we're going to be writing equations. We'll talk about functions at some other point. So it's really an equation that we're going to be using in order to make predictions based on that line that we draw, not using the points that are given to us originally on the graph. We'll see that. The most common way to find the trend line is to use the eyeballing technique, which is really quite horrible because there's no formal way to say, well, this is the actual line that best fits this trend. So as it turns out, some of your answers will not be exactly the same ones that I get. It will also not be the same ones that your neighbor gets, and you shouldn't cheat anyways. So that makes it kind of hard to grade. But in any case, we are just kind of estimating some values on these. Simply try to draw a straight line that best fits the data. Use a ruler for accuracy. You should use a ruler if you have one. If you don't, then just try to make sure it's a straight line. Here's what we can't have. So let's say that over here on this graph, you say, hey, this is a straight line, Mr. Sal. No, you messed up on that. That is not a straight line. It would be unacceptable. Or you drew something like this. No, that's garbage.
It looks like a mountain.
I mean, you know, there are some unfortunate diseases which would cause this, but
What are these graphs about?
I would know if you had such things. So really what we're going to want is a nice straight line that looks something like these. Now is that perfect? No, it's not perfect, but it will do, okay? Because this is just eyeballing it. Did I use ruler? No, I did not. Is it okay? Yes, it is.
Could you use a ruler?
Now again, yours, yeah, you should use one if you have one. Now your line may be at least slightly different than this one. It just can't be, we can't say, well, this one really represents the data right here because it's kind of going through the points, right? Like if I erase that one that I had. No, that's garbage. No, it wouldn't be something like that where you'd say, well, I really want to draw a line that looks like this. No, you see that you're getting farther away from the points as it goes upwards like this, so that also will not work. No, you can't put an arrow. It's not the arrow that makes it wrong. It's that it doesn't fit the points that are given to us. So
So you just have to go in the middle.
through the points, you got to make a line that best fits the points. Bam, I like that one. That one looks really pretty. So now we're ready to solve the rest of this garbage. All right, in any case, so this one, the observation that I'm going to make, the x values, no, I don't want the x values. No, not the x values.
Values.
Yes, I want to say that the y values are increasing, meaning that on the graph it's going upwards, as the x values, I didn't need a period, but whatever, x values increase as well, providing safely for us a positive sloppage. So as we can see on the graph right here, see as the y values are going upwards, the x values are going upwards too. I mean, I guess it really wouldn't matter if we switch those around. X's are increasing, going to the right, and also the y's are going upwards as well. We know this because it has a positive sloppage. From left to right, it's going upwards. That seems a little redundant, but it hopefully makes sense. We already used a ruler to draw the, well, not a ruler, but we drew the trend line. So I need to find 2 points that I can use. After I've drawn the trend line, I ignore the points that were on there before. Meaning I'm not going to use any of those points to figure out sloppage or the y-intercept at all. So the point that I can see right here, I've got a point right here at 2, 0. But then I've also got this point up here at 8, 10.
But that's not. Oh, you just.
Now again, this is eyeballing, so you may have used different points and your slope may be slightly different as well, which is okay. Sloppage. So we got 0, 2, and we got 8, 10. So I'm going to use the rainbow method on this. From 2 to 10, I got my sloppage, which is going up 8. And from 0 to 8 is to the right 8, which gives me a sloppage of 1. So down here I can fill that in, that my sloppage is 1. Now in that it shows that m with this little squiggly equal sign, that's because it's an approximation. Of course, that means that yours may be approximately different than what I have, and that's okay. So if you got something like 0.9 or 0.11, we're still good there, okay? Now we need to find the y-intercept, and yes, it did give us the y-intercept right here. 0, 2, so I'm going to fill that in down here. 0, 2. This is enough for us to write the equation. They called it the prediction function. In any case, we're going to write that in slope-intercept form. So we got the sloppage down here, or right there, 1. And the Y-intercept is a positive 2, bam. This is the prediction function. Now this is where things get really, really tricky for us. Well, not tricky, but manipulative, if we want it to be. Because let's say that I was some kind of person that wanted to manipulate the minds of the public, and I would show this, and I would say, oh, this function's good enough for my benefit. So what am I going to do? I say, well, look at this, public, ignorant public. When x is 12, I'm going to replace the x down here with 12. I'll keep that x actually. So y equals 12 plus 2. And so y equals 24. So I say, using this data, using those points that I had before, and now I've drawn a line that is subjective because we're eyeballing it. And then I say, hey, look at this. If this continues in year 12, for some reason, then y will be 24, and then people gasp and wonder why things went so bad, and then I blame it on someone else. And then I say, vote for me. This will not happen if you vote for me. You see what I'm saying right there? Thank you. So, let's make that 14 instead, because that's 14.
Yeah, I was gonna tell you that.
Well, why didn't you? Dang it.
Because I was raising my hand and you're like, yeah, if you vote for Josh.
Well, that's because you had your hand up. All right, the other one it wanted us to do was when x was it 100? So let's replace x then with 100, and then predict what the y will be. Well, what's 100 plus 2? 102. That may come as a surprise, but those are the two answers for that. When x is 12, y was 14. And when x is 100, y was 102. So this is this answer for part E. We got the prediction function, we got the estimated sloppage and Y-intercept, and we have the observations in the drawn line. Number 2, there is our, well, these would be scatter plot, and they've already graphed the points for us. That's very nice of them. So we need to make some observations about these. Let's go ahead and put this one in. So as the x values increase, so going to the right is what that means. The y values decrease, meaning that it's going downwards, giving us
That's not a word.
a negative sloppage.
Get that on video of me burping.
I got that. Okay. Using a ruler, draw a trend line through the data points that captures the general trend of the data. All right, this time I will use a ruler, but it's not really a ruler. It's just technology. Oh, that's not a line. Let's try a line. That should be better. All right. I got my line right here. Now this is the one that I like. But again, if yours was a little off, maybe something like this, or a little bit downwards like these, that's still okay. All of these are good. Me too. All right. But again, it's just important for you guys to realize that you may be using a different line, which is, again, okay. So I've got 2 points that I can use to find the sloppage. And the first one I got there is 0, 8. That's kind of the beauty of eyeballing this stuff, is I get to kind of make that point pretty convenient. Now, we can't always make that extremely convenient like it is there. We'll see that. But in cases where we can, then maybe it's good that we should. Then I've got this other point. It looks like it goes through this point, actually. I've got 8, 4. So this time I'm going to use the right triangle to solve these. From 8 to 4, I went down 4, so my sloppage is down 4. And then we went to the right 8, making this a sloppage of negative 1/2. 2/5 is close enough. Negative 2/5. It should be negative though. But negative 1/2 is what I got. So again, your answers may be different.
Yeah, because you might have a different.
What you can't have is something like negative 3. That's too steep. You can't have negative 1 because again, still too steep. And you can't have something like negative 1/10. That's not steep enough. All right. Well, the Y-Intercept, I already found that up there. I had 0.8 as my Y-Intercept. Again, you may have gotten something different, something like, I don't know, 7.75 or some kind of improper fraction. All right, now that I have that, I can write my prediction function. Y equals the m, and we already have that as negative 1/2. And the Y-Intercept was 0.8. So this is my prediction function. So again, this is where, like if you were some kind of in the public eye somehow, you could say, look, when I've been doing stuff, how something bad has been decreasing, and then you emphasize that it's going downwards. So if you continue to stick with me, we'll go and stop it altogether. Alright, so we got that prediction function, y equals negative 1/2. Negative 1/2 times x. But down here they told us that x is 12. And so I'm just going to replace the x with 12. And then of course we got that plus 8 for me. Again, yours could be a little bit different than what we have right here, and that's okay. It's not going to make any difference as long as you're pretty close. So when solving at these, negative 1/2 times 12 gives me negative 6. Y equals negative 6 plus 8. And then negative 6 plus 8 is 2. So y is 2. That's one of our answers. Y is 2. And then we're going to go in and replace x now with 100. So negative 1/2 times 100 is a negative 50. Plus 8 would be negative 42. So this was our first answer. This is our second answer. If you wanted to, you could write that as ordered pairs, 12, 2, and then 100, negative 42. All right, number 3, the scatter plot below shows the weight in pounds of a person who is on a strict diet. That's not Mr. Sell. I am on a strict diet of sushi, donuts, and bacon.
I think
All right. All right. Use a ruler to draw the trend line. Here we go. So again, yours could be slightly different than this one, but it should be pretty close. And that's what I'm going to go with right here. That's very, very, very nice. Because right here, now that we got this, let's go ahead and find good old sloppage. So I got this point right here, 0 and 180. And then I got this point right here, which is at 15, 130. So, when I find a sloppage, I can again use the triangle on these. I went down 50. So my sloppage right now is down 50. And then to the right, 15. And if I were to simplify this, I'd divide both these by 5, so negative 10 thirds. There's my sloppage, negative 10 thirds. If I recall correctly, we got something different in the other period, so again, it's okay. We should get something pretty close to that. All right, the next thing we want is the Y-Intercept, and yes, that was given up in count. The Y-Intercept is 0, 180. So we should be ready to write the prediction function. So y equals the sloppage, which in this case is negative 10 thirds, times x plus the Y-intercept, which was a 0, 180. So there's our prediction function right account. All right, down here, D, what does the slope represent in context? So we have to check the labels on these, and we can see that the Y is the weight, and the X is the time in weeks. And we got negative 10/3. So it appears that every 3 weeks you would lose 10 pounds.
Whoa.
Or you could say you lose 10 pounds every 3 weeks. What does the Y-intercept represent in the context? Well, 0 is the X value up in count. And we can see that is 0 weeks. And then the Y there is in weight. So it appears that the Y-intercept represents 180 pounds. Oh, pounds. In 0 weeks, or at the beginning. Predict the person's weight after 18 weeks. So weeks again is X. So when we look at the prediction function, Y equals negative 10/3. X right here is at 18 weeks. And then we're going to add the 180. So when I multiply these, I should get negative 60. So Y equals negative 60 plus 180. You can use your calculator to calculate that, by the way. Then Y equals 120. So what this means is that the person in 18 weeks should weigh 120 pounds. Now again, this was a little different in the other class. We got, I think, like 122-ish for that. But again, that's okay because we're just eyeballing a lot of this stuff. All right, number 4. The following scatter plot shows the burn time for candles of various weights. And again, it's showing us up in here that the burn time is the Y, and the weight in this case is the ounces, meaning that the burn time will depend on how many ounces the candle weighs. Of course, that should make sense. This would be before you're burning anything. I mean, we don't use these very often anymore, right? Because of all the houses they burned down. So, it says first,
Whoa, what the heck?
let us draw a trend line. So, again, I'm just going to use the technology for these. This one looks pretty good, but actually I'm going to move it down a little bit like these. Like right here. Alright, that looks pretty good. Now there is a Y-intercept though. There is a Y-intercept on these.
Oh, it's 0, 0.
Yes, very good. So write the prediction function. That's the first thing we'll do. Let's find the sloppage. And right account, I have this point at the origin 0, 0. And then let's see, another point that we may use would be something like this one, 640. So on these, yeah, let's use the triangle for these. So I would go up 40 for my sloppage. And then I would go to the right 6. And I can simplify this to be 20/3. So that's my sloppage so far. Y equals 20/3 X. And then we just got to check for the Y-intercept, which, again, we kind of assume right here. That is 0, 0. Now I got plus 0 there. You don't really need it. And we won't use it when we find the predictions for D and E. But that's okay. So explain the meaning of the sloppage and Y-intercept in context. So again, we got burn time and weight. So we could say the X. If the candle weigheth 3 pounds, then it will burn for 20 minutes. Now that's just a sloppage. We need to explain the Y-intercept as well. If the candle weighs 0 pounds, it will burn for 0, is it hours or minutes? Minutes, hours? Hours, okay, so this one up here, I gotta change this minutes to hours up in here too. That was hours.
Oh, 3 pound.
Alright, if the candle weighs 3 ounces, it will burn for 20 hours. Good, we fixed both. Use your prediction function to predict the burn time for the candle that weighs 40 ounces. Alright, so ounces again is x. So in this function, y equals 20 times the x, which in this case is 40. Alright, so if we continue to solve this, I get 800 thirds, which is the same as 266.6 repeating, and y, that's in hours. So if it weighed 40 ounces, we should get 266.6 hours. Alright, what if the candle burns out at 500 hours? Well, hours is the y, so I'm going to replace the y with 500. So I got 500 equals 20 x. And I'm just going to solve for x by dividing both sides by 20 thirds. So I'll divide 500 by 20 thirds. And what do we get? 4, 20, 60. So this candle would have to weigh 60 ounce. This is just solving a complex fraction right there. Software programs and graphing calculators can be used to draw trend lines. You just can't use these types in this class. Izumi used a graphing calculator to generate a trend line for data on assists and rebounds. The graph below shows the trend line generated by the calculator. It's very nice. The problem is that she found that there's this point right here. That is what we would call an outlier. This one right here. Which means the point doesn't fit what's happening. So you see how that would be manipulative just to say I'm just going to leave it out. That's garbage. So I mean,
You could just shoot it.
what's stopping you from saying that one's garbage or any of these? But it does. That's the thing. So it says she may drop that one. Is it reasonable for her to drop the outlier from the data set? It depends. It depends on what the heck is going on. Like if someone did play or had 25 rebounds,
It's probably that person's just really
26
bad.
rebounds and 3 assists, that's reasonable. Maybe they just didn't play enough. Maybe they played a little bit and then got injured right account. But then it says assume this player joined the team midway through the season. Then yes. Then we would want to take that out because other people have been playing for a lot longer than that
And
person.
so they
Okay.
have real.
So she did drop the outlier, and it changed the line on the software, whatever they're using. And this is the interesting thing about outliers is there's a formal way to find the line of best fit. Just, we're not concerned about it right now, or ever in this class. So it says to analyze the differences in the two lines. What did the outlier do to the trend line generated by the calculator? Well, we can see that this line now is much steeper. Put on my desk. Is much steeper in terms of a negative sloppage. So in other words, it has just become more and more negative sloppage. Okay. And that should make sense, right? I mean, if with this point that was about right here, it should alter that line something like this, which is about what it was. Write a prediction function for the trend line generated by the calculator with the data set that was given, but it does not include the outlier. So it's the one that's given right here. Now this point right here That Y-intercept can't be known for sure, so we may have to do some estimation, but we can see that it definitely passes through this point, which is 50, 100. Now all the other points, we don't really see any other points that would be pretty good to use or easy to find in terms of the value of it. So I'm going to estimate the Y-intercept right now. And I'm going to say that that is at 0, 170. Right account. Now I can use the rainbow method on this one from 0 to 100. This is to find the sloppage. That would have went down 70. And from 0 to 50, that went to the right 50. So if I simplify this, I can get rid of the zeros and I can find that my slop is about -7/5.
You just said slop.
Or sloppage. It's all the same thing. Sloppage is the plural form of slop. All right. Now we need to find the Y-intercept. No, we don't. It was right there. We already estimated it.
Slopage was not plural.
Yeah, that's what I meant. All right, so Y equals -7/5 times the X, and the Y-intercept is a 0, 170. This will be the prediction function that we will use.
Have you always said, hey, how do you?
All right, explain the meanings of the sloppage and Y-intercept. Let's do these. So it's important again to remember what we're comparing. We got rebounds and assists. So when I put in the sloppage, we would say that you would lose 7 rebounds per every 5 assists. The Y-intercept, however, tells us that when you, or you, have 0 assists, you would have 170 rebounds.
What?
All right, use your function to predict the number of rebounds a player would have if they made 110 assists.
Oh yeah.
All right, assists are X, so this is our function, -7/5 X, but again, we're replacing X with 110, and then we will be adding 170. So when we multiply these, I got 22, 140, 154, -154 plus 170 equals a Y, and when I combine these, I get 16. So in other words, if you got 110 assists, you'd probably get about 16 rebounds. This makes sense if you understand some basketball. Usually people that get a lot of rebounds don't have a lot of assists. Usually those that have a lot of assists don't usually have a lot of rebounds. There are...
Because point guards have to pass, and then centers always put rebounds, and then they put it back up.
Yes. All right. Now it says, what about 150 assists? So let's look at that. Y equals -7/5 times 150. But again, we're going to add this to 170. So when I multiply these, I got -210 plus 170. And when I combine these, I get a -40. So in other words, if you have 150 assists, you'd have -40 rebounds. This is, well, it's impossible to get negative rebounds. You either have them or you don't. So in this case, this is unreasonable to expect this because we can only look in quadrant 1.
0 rebounds.
The lowest number of rebounds you can have is 0. Similarly, use your function to predict the number of assists a random player would have if they made 150 rebounds throughout the season. Rebounds is the Y. So I'm going to replace the Y with 150. And this equals -7/5 X plus 170. So to solve these, I would subtract 170 from both sides. So minus 170 gives me negative 20 equals negative 7/5 x. So to solve this, I would divide both sides by negative 7/5. Divide by negative 7/5. And we find that x equals a positive 7/5, so 100/7. 14. X here equals 14 and 2/5, 2/7. 2/7 assists. You can have the decimal for that. I just don't know what it is because I don't have a calculator.